Okay, so in this video, we'll take up another example on Dijkstra's algorithm. So you can see you have been given a weighted directed graph and you have been asked to find the shortest path from the starting vertex P, denoted as S, as you can see. This denotes that P is my starting vertex or my source vertex. So starting from your source vertex, you have to find the shortest path to all other vertices. Okay, so let's get started. So what would we do? We would start, we would make this table. If you have seen my previous video, you will find that I found the shortest path by relaxing every edge and constructing this table. So how do we select a vertex? We select a vertex by looking at the edge weight. So these denote the edge weights. So starting from P, the edge weight to the vertex P itself. So if I'm at P and I want to go to P itself, what would be the cost? The cost would be 0. Now initially, I do not know the path to the other vertices in my graph. So they are labeled as infinity. Since I do not know the path from P to Q, initially I do not know the path from P to Q, the value is infinity. The cost is infinity. I do not know the path to R, so the cost is infinity. I do not know the path to T, so the cost is infinity, and so on. So now out of all these vertices, I'll choose the one which has the least cost. So which has the least cost? P. It has a cost of 0. So I'll write P here. So I'll select vertex P. Now after selecting vertex P, I will list out all the outgoing edges from P. So what are the outgoing edges from P? If you look at the graph carefully, you will find that P has a few outgoing edges. P has a few outgoing edges. Now the first outgoing edge is towards Q. So PQ is an outgoing edge and it has a weight of 1. PS is an outgoing edge and it has a weight of 6. And PT is an outgoing edge and it has a weight of 7. So what I'll be doing is I'll be relaxing every edge. I'll be relaxing PQ, PS and PT. So let's start one by one. Let's start with PQ. So I'm trying to relax this edge. I'm trying to relax PQ. So what will I do? I'll use this formula for relaxation. So I'll see whether the relaxation will be possible or not through this condition. So what is my U? My U, see, my edge is V comma U. So U will be, so I'm trying to relax. Okay, let me write it down. Let me write it down for you. I'm trying to relax the edge P comma Q. I'm trying to relax the edge P comma Q. So here from this edge I can understand that V, see, what is the order? The order is V comma U. So here V will be P and U will be Q. U will be Q. Okay, so this is Q, right? U will be Q. Okay. Now, next thing that I have to check is that what is my source? So my source remains constant. My source is always the vertex P. My source is always the vertex P. Now I'll calculate these distances. So what is du? What is the distance of U? So du denotes the distance from the source to vertex U. Which is my vertex U here? Q. What is the distance from my source, which is vertex P, to my vertex U, which is Q? The distance is infinity. So du currently is infinity. What about dv? dv, okay, du is nothing but dq and it is currently infinity. Now what about dv? dv is nothing but dp and that is dp is, what is dp? What is the distance from P to P itself? See, the distance from P to P itself is 0. And what about the cost? The cost of V comma U. The cost of V comma U is nothing but the cost of, what is V here? V is currently P and U is currently Q. So what is P comma Q? The cost of P comma Q, as you can see, is 1. So the cost is here, the cost is 1. Now you check the condition. So what is the condition? The condition is if du, what is du? Du is infinity. Is it greater than dv? What is dv? 0 plus the cost. What is the cost? Cost is 1. So is infinity greater than 0 plus 1? Yes, this condition is satisfied. Since this condition is satisfied, what will I do? I'll update my u. How will I update my u? I'll update my u by adding the cost and the distance. So what is the distance? The distance is 0. See, I have to add dv. What is dv? dv is 0. And what is my cost? My cost is 1. So 0 plus 1 is 1. So now du will become 1. So du means your dq, the distance of q becomes 1. Okay, so I've relaxed this edge p comma q. Next I'll relax the edge p comma s. Now I'll relax the edge p comma s. So I'll relax the edge p comma s. So what is v? V is p, u is s, and my source remains the same, it's p. Now du is, in this case, u is my s. So I'll write s here. Now what is the distance to s? The distance to s from p is infinity. So here I have infinity. Distance is infinity. Now what about dv? dv is distance of p from p itself. Okay, this will remain p. So distance of p from p itself is 0. Now I'll check cost of v comma u. Cost of v comma u is nothing but cost of p comma s. So what is cost of p comma s? Look at this. P comma s is 6. So the cost is now 6. The cost is 6. Now I'll check the condition. So what is the condition? Is du. What is du? du is infinity. Is infinity greater than dv 0 plus the cost? Cost in this case is 6. So is infinity greater than 6? Yes, the condition is satisfied. So I need to update my du. So how do I update my du? I'll update my du as dv. What is dv? dv is 0 plus cost of v comma u. Cost of v comma u is 6. That means the cost is 6. So now s becomes 6. S becomes 6. And the next edge that I need to relax is p comma t. So now I'll relax the edge p comma t. So my v is p and my u is t. Now see du. du is nothing but du. What is u? u is t. So distance of source. What is my source? P. Distance of source vertex p to the vertex t. What is it? Infinity. So the value is infinity. The value is infinity. Now what about this? Remains unchanged because v in this case is p and the distance of the source vertex to the source vertex itself happens to be 0. So now what will I do is I'll see the cost. What is the cost? Cost of v comma u is cost of p comma t. So what is cost of p comma t? See, p comma t is 7. Cost of p comma t is 7. So this is nothing but 7. And now I'll check the condition is du. What is du? du is infinity. Is it greater than 0 plus 7? Is it greater than 0 plus 7? Yes, it is. The condition is satisfied. So what will I do? I'll update my du. I'll update my du as dv. dv is 0 plus my cost, which is 7. So now the distance from p to t, it becomes 7, right? So the remaining vertices, the cost to the remaining vertices or the distance to the remaining vertices remains the same. Now out of these 4 vertices, in fact out of these 5 vertices, the minimum is q. The minimum distance is that of q. So what will I do? I'll select q. So I'll select q. P has already been selected. Now I select q. Now after selecting q, I'll see all outgoing edges from q. How many outgoing edges are there from q? I'll have an outgoing edge to r and I have an outgoing edge to s. So let's write down my outgoing edges. Let's write down the outgoing edges from q to the remaining vertices. So if you observe carefully, the outgoing edges from Q, the outgoing edges from Q are, one is S, so Q comma S is an outgoing edge. Q comma S is an outgoing edge and it has a weight of 4. And another outgoing edge is Q comma R. Q comma R is another outgoing edge. So these are my two outgoing edges. See, 1, 2. No other outgoing edges. This is an incoming edge and that's it. Yeah, there are 3 edges incident on Q. Out of them, 1, 2 are outgoing edges and this one is an incoming edge. Now I have to relax these 2 edges, QS and QR. So let's start. So the first edge that I'm trying to relax is Q comma R. So let's try to relax Q comma R. So what is the value of V? V is currently Q. And what is U? U is currently R. My source vertex obviously remains the same. So du means dr. So from the table, I can see that the distance to R is infinity. See, the distance to R is infinity. You'll always look at the row. See, I'm currently at this row. I'll just look at the row above it. So if I look at the row above it, I can find that the distance to R is infinity. The distance to R is infinity. Now what about dv? dv means, what is your v? V is q. So I want to find dq. Now what is the distance to q? Look at the row immediately above. So what is the distance to q? The distance to q is 1. The distance to q is 1. And what about the cost? The cost of q comma r. The cost of q comma r is 1. So the cost of q comma r is 1. The cost is 1. Now I'll check du. What is du? Infinity. Is it greater than dv plus cost? What is dv? dv is 1. dv is 1. And what about the cost? The cost is also 1. See, this condition is satisfied. So I need to update my du. I'll update my du to dv plus cost. So what is dv? dv is 1. What is the cost? The cost is also 1. So now the distance becomes 2. So the cost to u, the cost to r becomes 2. Okay. Now the next edge that I want to, I've relaxed this edge. Now I'll relax q comma s. So let's relax q comma s. My v remains unchanged to q and my u is s. Now see, what about du? du now is ds. So what is the distance to s? Distance to s is 6. So distance to s is 6. Distance to q remains unchanged. See, the distance to q is 1, remains unchanged. What about cost of v comma u? The cost of v comma u is cost of q comma s. So what is the cost of q comma s? The cost of q comma s is 4. So this is 4. Now you check. What is your du? du is 6. Is 6 greater than dv? 1 plus the cost. Is 6 greater than 5? Yes, 6 is greater than 5. So the condition is satisfied. Since the condition is satisfied, I need to update my du. So now ds will be the value of dv, which is 1. dv is 1 plus cost, which is 4. So 1 plus 4 will be 5. So du, that means ds, becomes 5. So I've relaxed these 2 edges. Now I'll only write down the cost of the vertices which have not been chosen so far. See, I've chosen P, so I'll not write down anything against P. I've chosen Q, so I'll leave it blank. Now Q and S, sorry, R and S I've found to be 2 and 5 respectively. T is 7 and U is infinity. Now out of all these 4, which is the vertex having the least distance? It's R, so I'll choose R. R has a value of 2, so I'll choose R. Now after choosing R, I'll see all outgoing edges from R. Now if I look at the outgoing edges from R, there is an outgoing edge to U. There is an outgoing edge to U and it has a weight of 1, and there is an outgoing edge to S. There is an outgoing edge to S and it has a weight of 2. There's an outgoing edge with a weight of 2. Okay, now let's relax these 2. Let's try to relax R comma U. So I'm trying to relax R comma U. So what is V? V in this case is R. And what about U? U in this case is U, the vertex capital U. Now du, what is du? See, U is the vertex capital U. Now look at the row previous. What is du? It's infinity. So U in this case, the vertex U has a cost of infinity. That means I do not know the distance to U from my starting vertex P. I do not know it so far. That's why I mark it as infinity. What about dv? dv is, what is v? V is R. So dv is how much? See, dv is, look at this previous row. Look at the value of R. The value of R is 2. So I've already chosen R. I can strike it out. So its distance is 2. So its distance is 2. Its distance is 2. Now, what I'll do is, I'll see the cost. So what is cost of v comma u? Cost of v comma u is cost of R comma u. So cost of R comma u. So what is cost of R comma u? It's 1. Now, if you check the condition, what is du? du is infinity. Is infinity greater than dv? dv is how much? 2 plus the cost, which is 1. Yes, infinity is greater than 1, so the condition is satisfied. Now I need to update my du. So what will I say? I'll say dv plus cost, which is 3. So now du becomes 3. That means, what was du? du was the vertex capital U. So its distance becomes 3. Now next edge I'll relax is R comma S. So let's relax the edge R comma S. U is now the vertex S. Now du is ds. Look at the distance to S, it is 5. So ds is 5. And look at the distance dv. What about dv? It's dr. So dr was 2. So it remains 2. And what about cost of v comma u? Cost of v comma u is cost of R comma S. So cost of R comma S is 2. So cost of R comma S is 2. Now you check. What is du? du is 5. Is it greater than 2 plus 2? See, dv is 2 and cost is 2. Yes, 5 is greater than 4. So I need to update my du to 2 plus 2, which is 4. So now my du means my ds, the distance s, it becomes 4. From 5 it becomes 4. And the remaining ones, see, R has already been chosen, so I'll leave that blank. I'll fill up T. Now out of these three, which has the least weight? U has the least weight, so I'll choose U. So after choosing U, I'll see all outgoing edges from U. I'll see all outgoing edges from the vertex U. So from the vertex U, see, I have no outgoing edge from the vertex U. All these three edges which are incident on U, these are all incoming edges. These are all incoming edges. So what will I do? I'll not be able to relax any edge, so I'll leave it as it is. Now at this point I have two vertices, 4 and 7. Now out of these two, out of S and T, obviously 4 is smaller, so I'll choose the vertex S. Now look at vertex S. Vertex S has an outgoing edge towards T. I'll keep that because T has not yet been chosen, and its weight is 3. I have an outgoing edge to U, so I'll choose that as well. Will I choose that? No, I'll not choose this. Why? Because U has already been selected. See, there is an outgoing edge towards U, but U has already been chosen, so there is no need of relaxing this edge. Now look at this. Is there any other outgoing edge? This is an incoming edge, this is an incoming edge, and this is an incoming edge. So I need to relax this edge, S comma T. So let's try to relax this edge, S comma T. So my edge is S comma T. That means my V is S. My V is S, and my U is T. My source vertex remains the same. Now du means my distance of T. So what is the distance of T? The distance of T is 7. So the distance of T is 7. What about distance of V? Distance of V is distance of S. What is the distance of S? If you look at the previous row, the distance of S is 4. The distance of S is 4. And what about the cost? The cost is 3. So here my cost will be cost of S comma T. Cost of S comma T will be 3. Now you check. So what is the condition? du. Du is 7. Is it greater than dv, which is 4, plus the cost, which is 3? Is 7 greater than 7? No, obviously not. So there is no need to make any updation. Okay, so this was the only edge I needed to relax, and I've done that. Now after this, now since I have selected S, the only vertex remaining is T with a value of 7. So now I have no other choice but to select T. Now after selecting T, you can find all outgoing edges from T. Look at the outgoing edges from T. Now see, T has an outgoing edge towards U, but I'll not be considering this edge because U has already been chosen. So there is no need to relax any edge towards U. I do not need to relax any edge that is going towards a vertex which has already been chosen. See, T has an outgoing edge towards U. Now vertex U has already been selected, so I do not need to relax this. And this was the only outgoing edge from T. So this is the entire table that you can see. Now what I'll show you is, I'll show you the final answer. How you write the final answer. I'll show you that now. So let's look at the final answer. So I've written, so SP stands for shortest path. SP stands for shortest path. Now see, shortest path from P to Q. How do we find it? Look at the column for Q. This is the column for Q. Now you start from the bottommost row and you keep going up till you find the first entry. So I'm starting from the last row. This entry for Q is vacant. It's vacant, 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 vacant. Yes, first non-vacant entry. So I'll choose the first non-vacant entry. This is the first non-vacant entry. So the shortest path is 1. Now, what about R? Look at R. This is the column for R. I'll look for the first non-vacant entry. Look for the first non-vacant entry from bottom to top. So what about R? What about R? So vacant, 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 non-vacant, 2. So the shortest path for R is 2. What about S? Vacant, vacant, first non-vacant entry. So it's 4. This is 4. Vacant, non-vacant, first non-vacant entry. So shortest path to T is 7. What about U? Vacant, 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 first non-vacant entry, 3. 3. So that is the shortest path to U. Okay, so this is how you would find the answer. So this is the answer for the shortest path from the source node P to all other vertices of the graph. So I hope this helps. You can leave your doubts in the comment section below. Thank you.